For switches, it received a data. First it has to learn the MAC address. That is, the switch will record the source MAC of the received data frame and the information of the incoming interface. Now this data is sent from this PC. Enter switch. The interface of the switch itself is numbered. For example, this is the interface 1, interface 2, interface 3, interface 4 of the switch. It learns locally. It only needs to receive a data from this interface. It will look at the source MAC in this data and record it in the local MAC address table. So it will now record a interface 1 corresponds to the MAC address AA. It learns like this. The first behavior after it receives the data is called learning. The next behavior is to forward. For forwarding, now it behaves differently. If it receives a data, it is a specific device to be sent to. For example, now it needs to be sent to PC2 specifically. Then it will look at the MAC address table locally. If the MAC address table has, then just retweet. There is a parameter in the MAC address table. Known unicast data frame. Unicast means this data is sent by PC1 alone to a certain device. That is, sent to a certain MAC address alone. And look up the table. If there is, it means that this data can know a clear destination. Known unicast data frame. If you know it, directly look up the table and forward it. What if you don't know? Now it's going to be B. But this doesn't have this BB. Then what should we do? If there is no that for this switch. Unknown unicast data frame. Now where does this data frame go? It doesn't recognize the purpose MAC. So now it will perform flooding. So if a data really comes now, it doesn't recognize the destination MAC. Then it will perform flooding. The action of flooding is to send a copy from all other interfaces. It's the same as the hub just now. It will also send. But you have to pay attention to the difference. The difference is that if there is one in the table, it will be unicast forwarded. Flooding if there is no table. If flooding, PC2 received, it will reply after receiving. When replying, this data enters the interface of the switch again. It learned again. After learning, its MAC address table can be filled. Then next time when the PC sends it again, it can look up the table and forward directly. This is how the switch works. Received a unicast data with a very specific destination. See if there is such a purpose MAC in the unicast data table. Check the table if you have. Flooding if not. After flooding, the device has finished learning. You can check the table next time. This is a processing action for unicast data. We may also have some broadcast messages. Suppose the destination MAC is now all F. When PC1 communicates with other devices for the first time. But I don't know the MAC of other devices. It has to send an ARP broadcast. Then on to the switch. The switch has received a broadcast data. Then don't think about it. Absolutely direct flooding. So you will find the switch will also perform flooding. But it's not mindless flooding like a hub. Received broadcast or unknown unicast will cause flooding. If you receive a known MAC in the table, it looks up the table. So this is one of the places where switches are better than hubs. It has a forward appearance. Multicast we are not discussing now. Radio is for everyone. Multicast is for a certain group. So if the switch does not enable any functions related to multicast. In fact, it does not know whether the equipment below is added to the group. So you can temporarily consider it the same as broadcasting. You will learn multicast when you reach the IE stage. We don't learn this technology now. Let's make a brief summary. For switches, it doesn't actually care about the IP address of the device. It does not care what network segment the device is. It only sees the second layer when looking at the data. Switches work at the data link layer. That is the second floor. Routers work at layer 3. After it receives a data. To decapsulate the message. To which level? If it demolishes the second floor. After reading the lookup table. Re-encapsulate the second layer before forwarding. Then it means that you only look at the content of the second floor in the whole process. Don't look at the third floor. This is called working on the second floor. For routers, after receiving, must see the second floor. First of all, the destination MAC is sent to it. Yes. Look at the third floor. In the third layer, we need to look at the destination IP address. Then perform corresponding routing function addressing and forwarding. So a router is a router that works on layer 3. For switches, work on the second floor. So all the IP-related stuff at layer 3. It doesn't care at all. Here are some differences between switches and routers. When we talked about routers earlier, basically all related to IP. The switch is not related to IP. I will make a simple explanation. If the interface of the switch receives a data, then it finds this data. It needs to be sent out from this interface. Then the switch will perform an action at this time, called discarding. It doesn't want this packet. So under what circumstances would such a behavior occur? We will not explain at this stage. When you reach the IP stage in the future, you will learn about layer 2 loops. When you encounter a loop, can understand this sentence. Certainly. If it receives a message, failed to pass the verification of layer 2 FCS, it also drops. So actually the switch it works is simple. Or retweet. Or flooding. Or discard. Let's take a look at the PPT's explanation of this. Let's sort it out. The first is flooding. Under what circumstances will we flooding? The switch received a data from an interface. If this data is a broadcast data, the switch is directly flooding. If the data is a unicast data, and there is no corresponding destination MAC in the MAC address table, then exchange chance flooding. So what is forwarding? The switch receives a unicast data, and there is this in the MAC address table. Then it forwards. And what is discarded? It's what I just told you. The switch finishes receiving data from an interface. Also send out from this interface. It will discard this data. This is the switch forwarding behavior. The switch also has a working behavior called learning. That is, learn autonomously. The switch can learn automatically. You don't have to configure it. So some people will say that the switch can be used when it is turned on. You don't need to configure it. That's why it works by itself. Here's some of how the basics of the switch work. Next, these are forward data frame, the initial state of the switch, learn MAC address. Let's take a look. Just started without a MAC. Sent a data. Learn the MAC under interface 1. Then broadcast. This is an ARP request. Obviously sent. Host B replies to host C. Learned host C under interface 3. This is the MAC address. It's the same as the picture I drew. It's just that it's painted more professionally. Next we start talking about VLAN. VLAN is called Virtual Local Area Network. V is virtual. LAN is local area network. Why do we have a virtual local area network? Let me first describe an environment. In the future, many devices will be connected to one switch. Suppose a switch is connected to 40 devices.